Hey everyone, um, my name is Ravi Evani, and I'm VP of Engineering in our travel and hospitality business. And I want to start off this talk by playing a 5-second clip on a recent achievement of mine. So, what you're seeing here in this clip was me and my 11-year-old son playing together to win the rarest pet in the called the Ultimate Overdrive Bunny in the game Legends of Speed on the gaming social network platform called Roblox. Now, getting in a position to win this pet takes hours and hours a day across weeks. And when you finally get to the draw, there is a 2% chance of winning this pet. And I'm glad to say that we finally made it. So, my son wins, adopts, trains, and raises these kinds of exotic pets, ranging from dogs to dragons, and then trades them with other players for even more exotic finds. And he doesn't just play the games on the platform, he also builds them. Roblox is a global gaming creative platform that disperses game creation tools to millions of people, mostly kids, and those little creators disperse games to tens of millions more. The creators earn in game currency called Robux, and trading the creations, such as pets, in exchange for Robux has created a mini economy within Roblox. So, why am I talking about Roblox? It's an example of one of the trends that encapsulates the reshuffling of stakeholder value due to the pandemic. During COVID, the number of daily active Roblox users was up 82%, and the amount of time those users spent engaged on the platform more than doubled in the past 8 months. And Roblox now commands the attentions of America's kids to the tune of like 2.5 hours per day. And where attention goes, money flows. My son's birthday was last month. The past several birthdays, my son got a Lego set. But guess what he also got this time from his aunt? He got a Roblox gift card. And that is a direct example of a rapidly changing consumer share of wallet. We spend our money on something today, and then something more easy or fun comes along, and we now spend our money on that, which means that businesses are having to strive harder than ever before to maintain and grow their share of wallet with consumers. And that means more than ever before, they have to accelerate the pace of digitally transforming themselves. So, what does this mean to us as engineers, right? It means that in order to help businesses accelerate the pace of bringing digital ideas to life, we have to drastically reduce the level of effort it takes to build digital transformation solutions. So how can we do that? So let's go back to the Roblox example. So there's 40 million games on Roblox now, mostly built not by professional game designers, but by regular people. And most of these games are made by kids. And they're all created in this visual designing tool plus programming IDE called Roblox Studio. But the most remarkable thing for me is that these millions of games are created by just around 150 components, which can be programmatically combined together in various ways in order to build these games. Roblox figured out a toolkit, a set of reusable components to help kid makers build and create worlds that hold the attention of so many people and keeps them coming back. Can we do the same? Can we build a set of reusable, fungible components in ways that can radically shrink the amount of effort it takes to bring digital ideas to life? Let's see how we could do that. So let's consider the example of an airline, right, that wants to transform its passenger experience across a variety of its business functions. And let us take three distinctive use cases related to its digital transformation across three different business functions of the airline. So, in the first use case, the airline's line personnel want to enable the quick transfer of their elite status loyalty passengers to their connecting flights by guiding them with the fastest path to their departure gate through their mobile or watch app. In the second use case, the airline sales and marketing teams want to push personalized offers to entice their customers to upgrade their flight. And in the third use case, The airline's customer service teams want to proactively determine at risk flight connections and notify their passengers in real time whether they might be able to make their connections or not. Now, if you look at this from a system standpoint, the solutions to each of these use cases seem distinct and oriented around separate business functions, right? Like sales, customer service, and so on. And traditionally, these types of solutions were built on siloed systems, like booking systems, notification systems, loyalty systems, which were built, deployed, and configured in a bespoke manner to serve that particular business function of the airline. But when we think about technology transformation, we must think of not of silos, but of reusable building blocks that are leveraged across these seemingly disparate and siloed use cases. Like, digital transformation relies on an organization's ability to package its services, competencies, and assets into modular piece of software that can be repeatedly leveraged. So I want to introduce you to a concept that we've been experimenting with in travel and hospitality, and it's the concept of industry components, which will shrink the level of effort it takes to build digital transformation solutions. So, what do I mean by industry components, right? Industry components are reusable software components and services tailored to implement digital ideas in a particular industry, and they're built on top of cloud managed services. So, an industry component can be reused or leveraged across use cases, across business functions, and across enterprises within an industry. And because of the scale of reuse possible, they can radically shrink the amount of effort it takes to bring digital ideas to life for an enterprise. Now, some of you might be skeptical about this, right? I mean, we all know that reusability is an architectural principle, right? But in practice, we usually find ourselves not being able to reuse much across systems. I mean, Tilak also mentioned this as part of his Q&A, right? And the reason for that is because we typically build our systems to functional requirements. And because functional requirements are from an end user perspective, it seems that what we build is unique to those requirements. And it's hard to imagine building something substantial that can be reused across use cases, business functions, and enterprises, right? Now, this line of thinking that large scale reusability in bespoke software development is not practical might have been acceptable a few years ago. But with the way cloud services are evolving, things have changed dramatically. The cloud has transformed the way we think about reusability. For example, today it is pretty evident that the same cloud components can be reused across a wide range of businesses, right? From a small restaurant franchise to a large investment bank. We could be using the same infrastructure building blocks, but 10 years ago, almost every IT leader thought that each of their applications was a unique snowflake and that their infrastructure needed to be built in a bespoke manner to serve their enterprise needs. And the thought of reusing the same infrastructure components across multiple business functions, let alone with other enterprises, would have been deemed inconceivable. But today, we can't imagine building a digital product that doesn't reuse or share compute, storage, networking, and another cloud components in one form or the other, right? And we are now able to bring this type of engineering all the way up to the application and user experience layers. Let's see what this could look like in practice. So, in order to illustrate the example of industry components and how they can materially reduce the effort it takes to implement digital transformation solutions, let us explore the engineering for this use case, where the airline's line personnel want to fast track elite loyalty passengers to the departure gate of their connecting flight via the passenger's mobile device. Now, the core of the solution to this problem is that in order to fast track a passenger, we would need to predict the optimal passenger route from where they are to their connecting flight gate and navigate the passenger there. So, in order to make this prediction, we need a bunch of data, such as airport data, passenger data, baggage and loyalty data, and so on. We also need a bunch of real time and streaming data that is occasionally changing, no, actually constantly changing, and can affect how we guide the passengers to the connection gate, like which areas of the airport are busy. Like we need things like wait times and security lines, as well as the exact passenger location at any moment in time for those passengers who who have opted in to share their location with the airline for this convenience. So let us progressively look at the components that we need to build to predict the optimal passenger routes to their connecting flight gate. Now, the first couple of steps here are to ingest, clean up, and organize all of this raw data to make it ready for training ML models. And for this, we need ETL components and big data processing components that run on frameworks like and engines like Apache Spark and Hive. And we also need components running on stream processing frameworks like Kafka to process the streaming data. Now, here is where the power of cloud comes in, the reusability of components across use cases and business functions. So we centralize the metadata of all the data elements we need into a data catalog, which means that the information around the data elements needed across the use cases and processing rules around them are all cataloged in a centralized configuration, and our ETL, EMR, streaming, event processing components all implement logic externalized from the specific data element. So, in other words, the exact same ETL component is reused to process a variety of data elements that have different sources and targets, right? But are physically and semantically similar. So for example, let's say you're transforming location data, right? Whether it is passengers' current coordinates or the location of an airport security checkpoint or the location of a flight, all of these data elements can be handled with the same Spark component for data transformation, regardless of them coming from completely different data sources. And that leads to a huge amount of reduction in effort for data processing. Now, this type of technology helps us create industry components very easily. So here you see two industry components, like in the airline industry, right? So a data catalog component and an EMR component. And as I mentioned before, an industry component is built on top of a cloud provider managed service. And in this example, the data catalog is built on top of AWS Glue catalog, and the Spark application is built on top of AWS Glue. The Spark component running on EMR is using the data catalog on Glue as the meta store. And both the industry catalog component and the EMR component have extensions specific to the enterprise. So while passenger location data could be represented at an industry level, a loyalty ID and its processing could be enterprise specific. So this allows complete flexibility while enabling maximum reuse. Now, the beauty of this is that when we have these industry components built, the implementation of the next use case, even if it is for a completely different business function, becomes much simpler, right? So here you can see the second use case, which is about pushing location-based offers. And that needs a chunk of data elements that are needed by the first use case. And the third use case, which is about the airline's customer service function to determine at-risk flight connections, also needs a chunk of the same data elements needed by the first and second use case. And we don't need to rewrite a lot of this code again, which correspondingly reduces the development, QA, deployment, and DevOps time, and so on. So the bottom line here is that industry components will help with significant reduction in effort it takes to clean, transform, and organize data into data lake across industry use cases because of the large amount of overlap and relationships amongst the data within a particular industry. Now, the next step is to train ML models with the cleansed, raw, and curated data that is now readily available in the data lakes in order to make predictions. Now, the unique advantage we have with machine learning in terms of reusability is that whether the data is numerical, categorical, time series, text, or images, all of it is ultimately converted to numerical signals, which by nature makes the processing logic for reusability ready for reusability because regardless of the representations of the higher data level elements, they are all numeric in nature ultimately from an ML standpoint. So in the first use case, we are predicting the fastest route for the passenger to get to their connection gate. Now, this is a path prediction problem. And this same model could be applicable for other very use cases in the industry. For example, a hotel chain could leverage this to navigate their guest from the check-in desk to their hotel room. A restaurant chain could help their customer find their restaurant in a mall. An entertainment venue, such as a movie theater or a football stadium, could help navigate their customer to their seat. Now, in the second use case, we want to predict the best offer to show the customer to upsell them a flight upgrade. Now, this is a product prediction problem. And this same model could be used by a restaurant chain to upsell a sandwich to a meal, or by a hotel chain to motivate their guests to upgrade their room type, or by a rental car company to upsell a higher car make and model. And the third use case we want to predict whether the passenger would miss their flight is whether the passenger would miss their flight connection. And this is a time prediction problem. And the same model could be used by a restaurant chain to predict food delivery time or pickup time windows for their customer after they place their online order. Or this model could also be used by a hotel chain to schedule pickups for guests from the airport. So, therefore, looking at this, it is very inefficient for us to reinvent the wheel to recreate models across similar use cases across enterprises in an industry. Rather, we should be implementing these as industry components and accelerate the speed to market for digital ideas that can leverage these models. So, how do we make industry machine learning components that can be leveraged across use cases and enterprises? Here again, the power of cloud comes into play. Today, we have cloud tools such as if you look at the right, the TensorFlow Hub, on where fully trained models can be published and reused. It is possible to train a large model with the right algorithm and data. And from this large model, if you're just interested in a part of it for use in a different use case, business function or enterprise, then we could package that part into a saved model that is an independent unit of computation along with the weights that it is trained with. And this saved model can be shared and consumed and used to solve a completely different task, which is obviously related in terms of the pattern. It can also be independently tuned. For example, in the TensorFlow Hub, you can fine tune a model's weights and adjust them to a specific prediction problem after taking it out for reuse. And cloud providers such as AWS also provide features such as deploying TensorFlow models from Google Cloud, which are trained outside of AWS SageMaker, into a SageMaker endpoint, for example. So models can be leveraged across use cases and across business functions and across clouds. Now, here are some examples of industry components. I'm taking the QSR industry. So QSR stands for quick serve restaurants, like that's fast food chain, for example. And QSR, you have a lot of components here from a data processing and analytics perspective. We can build QSR specific components ranging from business analytics to graph schemas to workflows. Similarly, for machine learning, we could make components like voice recognition for food ordering, or text comprehension for customer sentiment, or fraud detection components for fraud related to deal redemptions, for example, and so on, and use them in multiple implementation. Now, the final step is to activate the experience on the channel. The two parts to think about here are the microservices fronted by the APIs and the front-end channel experience. Now, we all know that APIs are an easy way to integrate components together. And we saw Rakesh talk about this in detail. And we can build industry APIs designed with the developer experience in mind. And when made to be easily reusable, industry APIs will let us modularly combine and recombine functionality and data for new users with virtually no marginal cost for each additional use of the API. So, for example, in the use cases we've been talking about, if the line personnel business function builds a new API and let's say it funds the building of that, and that API, let's say it looks up passenger location, the marketing team can use the same API to target their location-based offer to the passenger without any additional work. So now if we just take the example of travel and hospitality industry, we can create many common APIs that can be reused across airlines, hotels, restaurants, cruise lines. And that includes capabilities like things like registration, checkout, offers and promotions, loyalty, location management, and so on that are common across many of these experiences. Now, let us take a look at this from a front-end user experience perspective. Now, we are looking at the airline use cases 2 and 3, and these are screenshots from two completely different brands serving two different business functions. One is for a deal upgrade, deal for an upgrade, and the other one is for a notification to find alternative flights. However, there is a lot of similarities in the UI elements, as you can see here. And ultimately, this is a call to action widget that we are looking at. So, how can we create industry level components like this, such as call to action, or a directions map, or a shopping basket, or a payment component that can be leveraged across multiple applications while being customizable at the same time? So the traditional challenge here has been that it has not been so easy for custom markup structures to be made reusable, right? So we are talking about HTML, style sheet, and JavaScript all bundled together as an independent component. And when we use all of these things multiple times, it could turn your page into a mess from a code perspective. But this problem has now been solved by web components, a technology that is now ready for prime time after maturing for the past 3 years. Web components is a combination of custom elements, shadow DOM, and HTML templates that allow us to create reusable custom components. We can encapsulate the functionality independent of our rest of our code and then utilize them in our web apps. And therefore, this makes it possible for us to build industry web components, which will enable a common model for components to be used and reused across use cases, applications, and enterprises, while allowing for a full parameterized customizability to meet a specific brand requirement. Now, we are also able to do something very similar with mobile apps, where through cross platform component technology like Flutter, we can create industry components as well as templates to assemble the components in different ways and deploy them across a variety of target devices. Now, this one is a pilot that one of my XT architects, Anurag Tyagi, is working on in collaboration with one of our hospitality clients. Now, here are some examples of industry web components that we could build for the QSR industry. So you will see that many of these are fungible for airlines, hotels, cruise line customer experiences also. So we looked at how the concept of industry components can be applied to real scenarios and how they bring reusability to at all architecture layers, thereby creating the potential to radically shrink the amount of effort it takes for digital transformation solutions. So here are some of the things I would encourage you to think about in terms of what you've learned here. If you are an engineer, you might think about how would I externalize, package, and distribute the modules, services, tool chains, and assets that I'm working on into industry components so nobody in my industry group needs to write the same piece of code ever again. And secondly, how can I interact, network, and collaborate with other engineers in my industry to make it easy to contribute and grow our pool of industry components so we can continue to improve our speed of software delivery and innovation? And if you're an engineering product or an account leader, I encourage you to think about how do I talk to my stakeholders and clients about the benefits of tapping into and growing our pool of industry components? How do I impress upon them that a symbiotic relationship with other business functions and enterprises through industry components will enable them to shrink their effort it takes to achieve their own digital transformation goals? Now, I know that some of you might be thinking, that I wish I could do this, but my stakeholders or clients will probably not allow it because what we are building is their IP. So, allow me to challenge you a little bit on that. We should be talking to our clients about what part of what we are building for them actually needs to be considered their IP. Yes, their data is their IP, their unique customer experience and product design is their IP, and some of the business logic that they have that needs to be unique to their company could also be their IP, but the rest of what they are building on top of is largely going to be cloud and open source anyway, right? So when you engage in that kind of a conversation, talk to them about the huge value that comes for free with reuse. And you might end up at a place of accelerating innovation versus being bogged down by legacy thinking. And the final point I want to make here is the challenge of it is not in the requirements. Nobody will tell us to build, share, and leverage industry components. Our client stakeholders won't, their customers won't, and our competitors won't. This is something that we have to own and do. And if we do that, we have the opportunity to start a virtuous cycle. Through reusable industry components, we'll find that we are able to get more done in less time with less people. And we can now use those resources to further accelerate innovation for our clients. And maybe just like Roblox components unlock the potential of creative kids, our speed of engineering with industry components can unleash the creativity of our clients to bring many more digital ideas to life for their customers. Thank you.